Section 4.4, Day 2, Logarithmic Functions and Their Graphs. Now, right out the gate, I want you guys to notice something. This little point right here, 1, 0. You know what? Well, I was going to sharpen my pencil, but that's saying x equals 1 and y equals 0. And if you think about it, if I turn this thing around and I go like this, and then I say, hey, there's a little e there, and I just plug these in and I say, all right, let's even see if this is true. There's an e there, there's a 1 there, there's a 0 there. All this is saying is e to the 0 power equals 1. So as you can see, this point 1, 0, 100% true for this graph. Over here, not quite the same, because if I was to say, okay, let's turn this thing around and go log, because there's nothing there, there's an implied 10, and there's my x, and that equals y. If I said, okay, that point 1, let 1 be x, then I'd go like this. I'd go log 10, 1, and then I would say 0. You know what? I'm catching myself here. I think this is just a big old misprint here. Because if you look at it, this would be true. 10 to the 0 power does equal 1. I was going by the picture. My bad. Anyways, this drawing is wrong. It should be more like this and then up like this. Now, what I want you to understand in this class, the difference between y equals log of x and y equals the natural log of x is very small, extremely small. This one's flatter. This one goes up a little faster, but I'm not going to be too worried about that, okay? The domain of the natural log function, you can see domain means x. In other words, how far left does it go? It gets to 0, but it doesn't touch 0, and then it goes on for eternity to the right, okay? Now the question is, why can't x be 0? If we go to here, and we say, all right, let's just investigate and put a 0 in there, and I raise e to some power, remember e is 2.71, 2.71 to some power equals 0, that will never happen. Same thing for this one right here. I cannot put a 0 in for x because 10 to any power will never, ever, ever give me 0. Okay? Also, x can't be negatives because, think about this, 10 to some power, will that ever give me a negative? No. So that means x can never be negative in either of these. That's why there's no domain to the left of the y-axis. So the domain here is the same, 0 all the way to infinity. Now this says solve the equation by changing it to exponential form. This is just review. So there's an invisible 10 down there. So I start with the base, and then I go to the exponent, and then I go to what we've decided to call whatever's in the answer position, and we're done. Now, yeah, maybe you want to make it 10,000, but whatever. It's the same thing. Again, there's a 10 there, so I'm going to go 10 to my power equals x. And that's just going to be 1 over 10 cubed, which would just be 1 over 1,000. Any one of these three is good, but I think this is probably the most simplified version. Now we're going back to our graphing days. This should be somewhat easy, okay? So remember, the basis of this is y equals a sine bx plus c plus d. All this stuff is very, very similar to what this is talking about. So, see there's a 1 there, so there's no change there. We have a negative x. That's just like a negative b. What does that do? It reflects it over the y-axis. What is that, negative 2? That negative 2 is our d, so that's just going to take it down 2. Again, we should be very good at this by now. We just should be. On this one, what I'm going to do is I'm going to rearrange it because this is more in tune with what we've been talking about, okay? So again, what's A? Well, it's 1, so there's nothing going on there. What's this? Well, once again, that's going to be over my y-axis. Now, this gets a little tricky. If this negative wasn't there, that plus would tell us left 5. But because it is there, this plus would now go right 5. All right, let's go on to this one. So this is just a log, we know what the drawing looks like basically from up here. But this is more of an exercise just to get back to our words and how to describe transformations. So this is a vertical stretch by a factor of 2. Right there, that's over the y-axis again. And that plus, because there's a minus there, is going to be right 1. Let's go on to this one. A lot more going on here. So that negative tells us it's going to be over the x-axis. The 3 means it's going to be a vertical stretch, factor of 3. I'm going to rearrange this as negative x plus 1 because now I can recognize what's going on. That's over the y-axis, and that plus 1 is going to be to the right 1. And the last thing is we're going to go up 2. So yeah, there's a lot going on there. And now they're going to actually have us do some of this, but these aren't too bad. So what we have to understand on this problem is the basic foundation is g of x equals the natural log of x, which we've already done right here. So it's going to go through 1, 0. We know that. It's going to follow the y-axis, but it's not going to touch it. And then it's going to be kind of flat, but it goes up. Okay? All this is saying is move it left 1. So I take this point and I go left 1. This, see the y-axis, I'm going to make it dotted. I wish these units were a little bit bigger, but oh well. And that means it's going to now go this way, and then it's going to go like this. Okay? So our final answer is right there. Final. But it's going to ask us a few things. What's the domain? Well, see this right here, the dotted line, the asymptote is x equals negative 1. So my domain would be parentheses, negative 1, all the way up to infinity, because it goes all the way to the right. What's the range? Well, the question is, how low does it go? Well, it gets down to negative infinity. And how high does it go? Well, it's awfully flat, but if this thing goes forever and ever and ever and ever and ever, it's going up. So that's going to go up. Remember, range means your y's, which means up and down. Domain means your x's, which means left and right. Continuity, yes. Increasing or decreasing, remember you have to go left to right to make this decision. Think of it as a roller coaster. So if we stayed on this forever, it'd be going up. So it'd be increasing. Asymptote, we already talked about it. Yes. X equals negative 1. Sorry. And now end behavior, that says, I'm going to blow it up a little bit, and you have to understand what that means. It means as x approaches infinity. Well, remember, this is infinity, this is negative infinity. So this is just a fancy way of saying move left to right. And the question is, end behavior is talking about the range. How low does it go? How high does it go? Well, if I move left to right along this thing, it's going up. So this would be positive infinity. All right, let's move on to this one. Again, what's the difference between the LOG graph and the LN graph? Not much. They both go through point 1, 0. Had a little hiccup here early, my bad. But now we know it does go through, so we have to understand what g of x equals LOGX looks like. Again, that's one of our main points is 1, 0. So our original, and it's going to go up a little faster, so I'm going to increase, probably more severe than it should be, but I just want you to show you a difference between this one and this one. But that's bothering me a little bit. It goes up a little too fast on that, so I'm going to flatten it just a little. All right. So, not done though. Got some work to do. What does that do? It goes over the x. What does that mean? Well, the top part now is going to go below. This bottom part is now going to go above. All right, that's just this step. Now I need to move it left 2. So this is the asymptote, but I need to move it 1, 2, just like this, and then repeat this dotted drawing. And see this point right here? That moves left 2 also, so it's a definite point I can make a target of. And then kind of like that. Is my drawing perfect? No. Will it get the job done? Yes. Domain. How far left does it go? How far right does it go? Now it might be bracket, it might be parentheses, so I better be careful, but how far left does it go? Well, it gets to the asymptote, x equals -2, but it doesn't touch it. So that'd be -2. How far right does it go? Well, it goes to the right forever. Range. How low does it go if it keeps going? Well, that'd be -infinity. How high does it go? All the way to infinity. Continuity, yes. Increasing or decreasing, this one would be decreasing because as I move on it left or right, it's going down. Asymptotes, x equals -2. I'll be careful on that. I'm going to blow it up so you can see it. X approaches infinity means go left to right. And what's the end behavior? You're thinking, how high does it go or how low does it go, which is another word for range. So, all right, left to right, and it's going down. So we know that'd be -infinity. And that finishes 4-4 day 2.